Something is wrong in deep space. An object from another star system is accelerating for no apparent reason, defying all the laws of physics we know. There are no gas jets, no gravitational influence that explains the phenomenon. 3I/Atlas, an interstellar comet that should follow a predictable trajectory, is being pushed by an invisible force. Scientists around the world monitor every movement with a mixture of fascination and unease. The question no one can answer: what is moving this object? And more importantly, do we really want to know the answer? Tentar Novamente. Since it first crossed our solar system, 3I/Atlas has kept the astronomical community on high alert. This interstellar comet, catalogued as the third confirmed object to visit our system from beyond the solar boundaries, is now once again exhibiting behavior that defies conventional explanations. New measurements reveal abrupt photometric changes and movement patterns that don't fit traditional models of cometary activity. What initially appeared to be just another cosmic visitor has transformed into one of the greatest enigmas of contemporary astrophysics. Astronomers from observatories around the world now face something that seems to go beyond simple gravitational explanation, and the implications of this discovery could be revolutionary. The first sign that something unusual was happening came from the object's brightness readings. 3I/Atlas showed sudden oscillations in its luminosity without any correlation to its distance from the Sun, completely atypical behavior for celestial bodies of this nature. Under normal conditions, comets increase in brightness as they approach our star and dim as they move away, following predictable patterns based on the sublimation of surface ice. The recorded light curve, however, tells a different story. The variations suggest irregular reflections of sunlight on its surface, or, even more intriguingly, possible internal energy variations that don't correspond to any known phenomenon. Instruments from multiple observatories, including state-of-the-art ground-based telescopes and orbiting satellites, independently confirmed these anomalies, eliminating any possibility of calibration error or instrumental failure. These photometric changes don't follow the expected pattern of rotation or surface activity. It's as if the object were pulsing in ways that defy our current understanding of how celestial bodies interact with solar radiation. But the real shock came from the orbital data. Precision astrometric analyses revealed that 3I/Atlas slightly altered its velocity and trajectory in a manner inconsistent with known gravitational influences in the solar system. All planets, moons, and other massive bodies were considered in the calculations, and yet a residual acceleration persists that cannot be explained by classical celestial mechanics. Most puzzling is the absence of visible gas jets emanating from the object. Normally, comets display tails and comas, clouds of gas and dust that form when volatile materials sublimate under solar heat. This sublimation process can create natural propulsion, functioning like small rocket engines that subtly alter the comet's trajectory. But in the case of 3I/Atlas, there's no visual or spectral evidence of this activity that could justify the observed acceleration. The parallel with Oumuamua is inevitable. The first interstellar object detected, in 2017, also exhibited non-gravitational acceleration that left scientists perplexed. On that occasion, natural and artificial theories were proposed, but no definitive conclusion was reached before the object disappeared from our observational reach. Now, with 3I/Atlas, we have a second chance to investigate this extraordinary phenomenon, and this time with even more advanced observation technology. The scientific community finds itself divided among multiple hypotheses, each with its merits and limitations. Among the most discussed natural models is the possibility of asymmetric ejection of invisible volatile materials, compounds that don't emit detectable light in the visible spectrum, but could still generate propulsion. Another theory involves deep heating of the object's core, where internal thermal processes would release energy gradually and asymmetrically. Some researchers propose that 3I/Atlas may contain reservoirs of highly volatile materials, such as molecular hydrogen or helium, that sublimate without producing the characteristic tails observed in conventional comets. These invisible jets could, in theory, explain both the acceleration and the absence of visible activity. On the other hand, alternative models, though in the minority, cannot be completely dismissed. Some scientists speculate about the possibility of artificial propulsion, an atypical internal magnetic field interacting with a solar wind, or even some type of technological response to external stimuli. These hypotheses, though controversial, are mentioned in scientific papers with increasing frequency. The reason the scientific community avoids premature conclusions is simple. Extraordinary evidence requires extraordinary proof. However, there's a growing consensus that we're facing a persistent anomaly, a phenomenon that resists conventional explanations and demands in-depth investigation. As one of the lead researchers involved in the monitoring stated, "We don't know what it is, but we know it shouldn't be happening according to our current models." The implications of this discovery transcend the object itself. The behavior of 3I/Atlas suggests that interstellar objects may carry physical mechanisms not yet understood by modern science. If these anomalies are confirmed and replicated in other cosmic visitors, we could be facing a fundamental gap in our understanding of astrophysics. A fascinating possibility is that the formation and composition of these objects are radically different from what we assume. Bodies that travel through interstellar space for millions or billions of years may have unique properties, shaped by environments we've never been able to replicate or observe directly. Accretion processes in distant molecular clouds, prolonged exposure to cosmic radiation, or even interactions with interstellar magnetic fields could result in structures with unexpected behaviors. More controversial, but impossible to ignore, is the question about a possible, directed origin of these bodies. If interstellar objects can exhibit non-gravitational accelerations without apparent natural cause, this raises profound questions about their nature and provenance. Is the universe filled with exotic physical phenomena we haven't yet catalogued? Or could we be witnessing something of an entirely different nature? Regardless of the final answer, 3I/Atlas is opening a new frontier for precision astrophysics and dynamic observation. The era of interstellar visitors has only just begun, and each new detected object expands our scientific vocabulary and challenges our certainties. The scientific community's response has been swift and coordinated. Space missions and large telescopes are already being reallocated to track 3I/Atlas's movement in real time. The James Webb Space Telescope, the Very Large Telescope in Chile, and various space observatories have directed their instruments to capture spectral, thermal, and astrometric data with unprecedented precision. International observation networks have been established to ensure continuous coverage of the object while it remains within reach of our most sensitive instruments. Each day of observation adds new data to the puzzle, refining models and eliminating inconsistent hypotheses. If the acceleration continues to be detected consistently in the coming months, we'll be facing the first solid and irrefutable evidence of non-gravitational force acting on an interstellar object, a historic milestone for science. This confirmation will require deep revisions in theoretical models and will pave the way for new lines of research in fundamental physics. What is pushing 3I/Atlas? The answer may redefine everything we know about motion in the cosmos, about the nature of interstellar objects, and, possibly, about our own position in the universe. While scientists work tirelessly to decipher this enigma, one thing is certain: 3I/Atlas has already secured its place in the history of astronomy as one of the most mysterious and challenging objects ever studied by humanity. The investigation continues, and the world watches.